This question asks, a 113 milliliter gas sample has a mass of 0.171 grams at a pressure of 721 millimeters of mercury and a temperature of 32 degrees Celsius. What is the molar mass in grams of the gas? So there are two ways that you can solve this calculation. So the thing we need to remember is that molar mass is grams per mole. So we have a mass, grams, and we could use PV equals nRT to find moles. So the first thing we're going to do is determine out all of our different variables. And so our temperature is 32 degrees Celsius plus 273. And so that gives me 305 Kelvin. The volume is 0.113 liters. I just divided by 1,000. And our pressure is provided in millimeters of mercury. So 721 millimeters of mercury. And I'd like to use this in atmosphere, and there are 760 atmospheres. Nope, there are 760 millimeters of mercury. Sorry about that. In one atmosphere. And so that gives you a pressure of 0.949. So now that we have these variables, we're going to look at two different equations on how to do this. And so the first one is going to use PV equals nRT, and the second one is going to use this equation where the density of the gas is the pressure times the molar mass divided by the R value times T. And what you'll see is these two calculations are both going to get you to the same answer. So I will show you both. So in option number one, the top option, we are going to solve for N. So N is equal to PV over RT. So when we plug that in, we get our 0.949 atmospheres, multiply our volume of 0.113 liters, divided by the R value of 0.08206 liters atmosphere mole Kelvin. And then we're going to multiply that by the temperature, which is 305 Kelvin. And so when you plug this into your calculator, you get that N is equal to 0.00428 moles. And because we know the mass and we know the moles, we can divide mass over moles. And so that gives us 0.171 divided by 0.00428. And this is in grams per mole. And that's going to equal 39.9 grams per mole. So this would be one way to do it if you didn't remember that the molar mass, which is the script em, is part of the density equation. So in this equation, we can solve for the molar mass, and that's going to be equal to the density times R times T over P. Now, what is the density of a gas? So in this case, the density is the mass over liters. This is usually in grams. So we have the mass, 0.171 gram, and we have the liters, so we can just plug this into our calculation. Or 0.171 grams divided by the 0.113 liters, multiply R, 0.08206 liters atmospheres mole Kelvin, multiply this by, again, our temperature, which is 305, still in Kelvin. We're going to divide that by the pressure, which is 0.949 atmospheres. And when we plug this in our calculator, we are still going to get 39.9 grams per mole. So both of these methods are equally correct, and you can use whichever one is easier or comes to mind during the equations.